Okay, the second section has to do with polygons. You know what a polygon is?
5 sides?
Doesn't necessarily, you can have a 5-sided polygon, it's called a pentagon.
Oh.
Okay, a polygon is just any figure that's made up of line segments that don't cross over itself and are not curved at all. So, that's a polygon.
Okay.
It's not a regular polygon because all the sides are different, but I could count up 1, 2, 3, 4, 5, 6. This is a hexagon. It's not a regular hexagon, but it's a hexagon because it's a 6-sided figure. You have 2 different types of polygons. You have, oh, it also has to be closed. So in other words, I can't just like go, oh, there, there's a polygon. No, it's got to connect, okay? It cannot have open spaces. But you have something that's called a concave polygon, and you have a convex polygon. 2 different types of polygons. Now, I'm a big person and looking at what's in there. Okay, so cave, you go into a cave, right? So here's an example of a concave polygon. Let me make that a little bit more pronounced here. Okay, the reason why it's concave is because if I extend any of these lines that make up this polygon, that goes inside my figure when I extend the line. Okay, in like a cave. So that becomes a concave polygon. Versus convex is normally what we think of more often. That's a polygon. If I extend any of those lines, do I ever go inside my figure? That's why it's convex.
Gotcha.
Okay, so that's simply all I have to do to determine which it is extend my lines and see if it goes in. If it goes in, it's concave. If it doesn't go in, it's convex. Once you do that, they might say, well, identify what shape it is. So I go, well, this is a 1, 2, 3, 4-sided figure. This is a quadrilateral. Obviously, it's not a square, it's not a rectangle, but squares and rectangles are quadrilaterals. So a 4-sided figure is called a quadrilateral. A 3-sided figure is a triangle. 4-sided is quadrilateral. 5-sided, what did I say before?
Pentagon.
A pentagon. 6-sided,
Hexagon.
hexagon. 7-sided,
I don't know that one.
heptagon.
Heptagon.
Heptagon, and remember the X comes before the P, that's how you can remember that 6 is the hexagon and 7 is the heptagon.
Got it.
Okay, what about an 8-sided?
Octagon.
An octagon. 9-sided?
I don't know.
It's called a nonagon.
Okay.
Okay, 10-sided? Decagon.
Decagon.
Okay, like a decade is 10, so it's a decagon. They never give you the term for an 11-sided. Don't know why, but they never do. If you want to know what it is, it's a hendecagon, but your book didn't give it to you, but I have looked it up. And a 12-sided is a dodecagon. Okay, so a decagon is 10, but a 12 is a dodecagon. Okay, you can look up like a 100-sided figure, and there are terms that are given to you. Sometimes they're universal terms, sometimes I can't decide on them, and there might be 5 different terms for a 100-sided figure. Okay, all you're responsible for is 3, 4, 5, 6, 7, 8, 9, 10, and 12. Okay? So if they ask you to identify it, you can go 1, 2, 3, 4, 5. Oh, this is a convex polygon that is a pentagon. Okay? If all of these sides have the same measurement and it's convex, okay, they have the same measurement and it's convex, then it's called a regular. Regular meaning all the same side, the sides are the same, the angles are the same. I'm not too good at drawing regular, okay, just to be honest with you. So if I could draw it where all the sides have the same measurement, like that, that's called a regular pentagon. Okay, all these angles also have the same measurement if it's a regular polygon. All right. You're going to classify some of these, so you'll look at it and they'll ask you some questions like they might say, name each polygon by its sides. So you count up the number of sides, you name the polygon. And then it says, oh, is it convex or is it concave? So then you look to see whether it closes in on itself. And then you'll say, is it regular or is it irregular? Do all the sides have the same measurement? Do all the angles have the same measurement? You cannot have a concave regular polygon. The only way you can have a regular polygon is if it's convex. Okay? Again, these are definitions. What if I asked you for the perimeter of something? What would that mean?
Add up all the sides.
Add up all the sides. So any polygon you have, you should be able to find the perimeter of, okay, by adding up all the sides. Unfortunately, what they do is they often put it on a coordinate plane. Okay, so once you put it on a coordinate plane, things change a tad because you have to use the distance formula to find between the 2 points. Like for instance, okay. Okay, let's say they wanted to find the perimeter of that. So I'm going to put it on a coordinate plane. And so this is negative 5, 1. And this is negative 1, 4. And this is going to be negative 6. Negative 6, negative 8. Okay, so then what I'm going to have to do is I have to use the distance formula to find the distance between these. Now I don't think, is the distance formula on your calculator yet?
I don't think so.
No. Okay, we will get it in there, okay, because at this point I'm going to let you use that. Okay, so right now you're going to have to use it by hand. Okay, the distance formula is your difference. We've already talked about this, okay? You've already been, the difference in your y's squared plus the difference in your x's squared. Okay, so this is going to be negative 3 squared, which is 9. This is going to be a positive 4, or negative 4 squared, which is 16. So you're talking about the square root of 25, which is 5. So this right here is 5. Then I would go on and do between these two. Or, I mean, it doesn't matter. So I have 1 minus a negative 8 squared plus negative 5 minus a negative 6 squared. So this is going to give me a 9 squared, which is 81. This is going to give me a positive 1 squared, which is 1. So this is going to be the square root of 82, which is not going to come out whole. So I'm going to round it. So I've got the square root of 82. Oops, I looked at the square root of 81. So this is approximately 9.1. Then I would do the same thing here. Then when I finish, I'm going to add them all up, and that's going to be my perimeter. Okay? What if I have something like this? And this will be the last thing. Now, this does finish the chapter. Okay, so what's going to happen is tomorrow we'll review it, Wednesday we'll test on it. Okay? Let's say that the perimeter of this, we know the perimeter is equal to 2 feet. And I have got a rectangle, and the only thing that I know about a rectangle is this is 3W and this is W. and they go, oh, you gotta find W. Okay, now, I know if this is a rectangle, if that's 3W, that's 3W. If that's W, then this is W. The perimeter is the distance all the way around it. So I've got W plus 3W plus W plus 3W equals 2. Okay, so when I add these all together, I've got 6, 7, 8 W equals 2. So W is equal to 1/4. So the W is 1/4 of a foot. Okay? All right. Homework. And I will grade your quiz and I'll give it back to you tomorrow, okay? So these two sections that we covered, and we covered them in a hurry, so cut yourself some, just try them, okay? If you get stuck, don't stress about it, just leave it, okay? Page 42, I want you to do, let's do 12 through 28 even. And on page 49, I want you to do 12, actually it's 49 and 50. I want you to do 12 through 34 even. And you've got 3 minutes. Okay.
I'll just go ahead and skip
Yeah, that's
this.
fine.